Hello and welcome to IGCSE Tube. So this is part number 8 of chapter number 14, organic chemistry. So in this part of the chapter, we are going to discuss this part of the syllabus, which is how to distinguish between saturated and unsaturated hydrocarbons through the molecular structure or by the reaction with aqueous bromine. So this is in section 14.5 of the syllabus. As I say at the beginning of each video, the syllabus I provided, the link to the syllabus I provided in the description box. So please make sure you access it and be aware of what is it that you will be tested on. So in addition to that, let me just zoom out a bit and get the highlighter. I'm sorry. So in addition to distinguishing between saturated and unsaturated hydrocarbons, I'll be listing the types of reactions that alkenes can undergo. If you have watched part number 6, it is the part where I introduced alkenes. In part number 7, I talked about how to manufacture alkenes by the cracking process. So I'll be talking about the different reactions that alkenes can undergo, which include addition polymerization. I'm not sure if this is really clear, and addition reactions with bromine, that is halogens, hydrogen, and steam. I really would recommend if you make the video full screen in order for you to be able to clearly view what I'm doing. So after listing the reactions, I will just be listing them. I will not be explaining them. These will be in parts 9 and 10. So in this video, I'll be discussing the combustion of alkenes and how it is different compared to the combustion of alkanes that I talked about in an earlier video. Okay, so let's get started. So, how do we determine if a hydrocarbon is saturated or unsaturated via the molecular structure? Saturated hydrocarbons contain only single carbon-to-carbon bonds. So, if, for example, alkanes, just like here, you only have single bonds. You don't have any sort of double or multiple bonds. When it comes to unsaturated hydrocarbons, they contain at least one multiple, which could be double or triple bonds. We have only been introduced to the double bond, and that's only the scope of this, within the scope of the syllabus, the double bonds. But also you should know that triple bonds do exist. So if the hydrocarbon contains a double or a triple bond between between two carbon atoms, for example in alkenes, then this is unsaturated. So that's how you can distinguish between a saturated and unsaturated hydrocarbon via the molecular structure. Just by looking at it, if it's all single bonds, you can definitely say it's saturated. If it has a double bond or a triple bond, you will say it's unsaturated. And this implies something. If you have all single bonds, you can also add hydrogen. You can also add anything, in fact, not just hydrogen. If you have a double bond, you can add hydrogen, because if this breaks, let me get the pen. If this breaks and it becomes only a single bond, so you can have here two bonds, because as you know, and as I have mentioned in previous videos, carbon can have only 4 bonds around it. So this is 1, this is 2, and because the double bond was 2, so it was 4. But now if it breaks and it's just 1, so it can take another bond here, so it becomes like 4. 1, 2, 3, and 4. 4 bonds around it. So you can add hydrogen or any other atom, kind of an atom, that we will be talking about addition reactions. That is, unsaturated hydrocarbons can undergo addition reactions, because if you break the double bond, they can take something else. Okay. I'm sorry. So how we now just talked about how to distinguish between saturated and unsaturated hydrocarbons via the molecular structure. Let's talk about how do you know if the hydrocarbon is saturated or unsaturated by the aqueous bromine test. So as the name suggests, the reagent that you use is I'm sorry, I thought that was the highlighter. It is brown bromine, it is aqueous, so it's brown aqueous bromine. The result is, if it is unsaturated, if there's a double bond, alkene, these are all synonyms, it decolorizes if it is unsaturated, just like the diagram here. So you place the solution of bromine in a test tube, so you have aqueous bromine, and then you add the hydrocarbon to be tested, and then you shake it. If the brown color disappears, which means it decolorizes, then the hydrocarbon is an alkene. You can definitely say that this is an unsaturated hydrocarbon. Okay, now let's go to the different reactions that the alkenes can undergo. Combustion, just like alkanes, there's complete and incomplete. You have addition reactions. They can add hydrogen, they can add halogens like chlorine or bromine. Halogens are group number 7 in the periodic table. And they can add steam as well, which is water. And they can undergo another type of reaction, which is addition polymerization. A really important note to make here is that as I mentioned in video in part number 7, alkenes are manufactured by cracking. So you cannot say cracking is one of the reactions that alkenes undergo. It's the reaction by which alkene is manufactured. So this is a really important distinction to make. Anyways, the addition polymerization is going to be discussed in part number 9. And addition reactions will be discussed in part number 10. The addition polymerization will be really a short video. I'm hoping to upload it along with part number 8 or shortly after. Okay, so before we end this video, we want to talk about the combustion of alkenes. So alkenes burn easily with a smoky yellow flame, and they give much heat. So it's really important to focus here on the word smoky. So if you remember, let's go back to the part where I talked about the alkanes. When I was talking about the combustion of alkanes, we said they burn easily, blue flame, much heat is given out. We didn't say there is a smoky flame or anything like that. So why is it that alkenes, when they burn, they give us a smoky flame? That's because due to relatively higher percentage of carbon compared to alkanes with similar number of carbon atoms. So what does that mean? So if we have 2 carbon atoms, okay, this will give us an alkene. The alkene with 2 carbon atoms is the ethene, and the alkane with 2 carbon atoms is the ethane. So this is ethane, and this is ethene. As you can see, the difference is in the number of hydrogen atoms, because we know that the general formula of alkenes is C2H2N, and the general formula of alkanes is C2H2N plus 2. Please watch the previous parts if you haven't, because it's really important and crucial for you to understand the subsequent videos or the following videos. Okay, so here you have 2 carbon atoms, but what is the total number of atoms in this hydrocarbon? It's 2 plus 4 hydrogens, so that's 6. So that's 2 over 6 is 1/3. In the ethane, you have 2 carbon atoms and 6 hydrogen atoms, so it's 2 plus 6, so it's 8. So 2 carbon atoms out of the 8, that makes just 1/4. So the percentage of the carbon relative to the entire hydrocarbon in the ethene is 1/3, while in the ethane it is 1/4. So it's a higher percentage. It's a much higher percentage, and that's why it leads to a smokier flame in comparison to alkanes, or a smoky yellow flame, and it gives much heat. I hope you got this point, but if you just can't really understand what I have said, just know that it gives smoky yellow flame due to higher percentage of carbon. Okay, complete combustion, that is when you have enough oxygen. So as I said, with the alkanes, it gives carbon. When you burn a hydrocarbon with enough oxygen, it gives you carbon dioxide and water. For the incomplete combustion, where you don't have enough oxygen, when you burn it with the oxygen, it gives you carbon monoxide, mono, not di, monoxide, and water. As you can see here, the equations are not balanced, because you have here 2 carbon atoms while you have here only 1. So you need to put a 2 here. So let's see the oxygen. So here you have 2 times 4 oxygen. No, let's balance. So we balance the carbon. Let's balance the hydrogen. You have 4 hydrogen. So you have here only 2, so you multiply by 2. Now the hydrogen is balanced. Now let's add up the oxygen. So you have 2 times 2 is 4. And you have here 2 times 1, so it's 2. So it's the total is 6. So what do you multiply by 2 to get a 6? You multiply here by a 3. Incomplete combustion. As I said, it's the only difference. It's instead of carbon dioxide, you got carbon monoxide. So let's balance the carbon first. You have 2 carbons, so you put here a 2. You have hydrogen 4. So in order to change this 2 to a 4, you multiply by 2. Let's count the oxygen. You have 2 times 1, so it's a 2. 2 times 1, it's also 2, so it's a 4. What do you multiply by 2 to get a 4? It's a 2. Now the equation is balanced. So I think I'm going to end this video here, but before ending it, I just want to say a big thank you to all of you. The IGCSE Tube now have over 800 subscribers, and that's something that I'm really happy about. I'm really sorry that I'm not uploading regularly, but I promise to be uploading more, and I'm getting lots and lots of questions via email and on my videos, and I really promise to get to each and every one of you. So stay tuned. If you haven't subscribed yet, please subscribe and give this video a thumbs up. If you have any question, leave it in the comment section below. And if you're going to take the exam, you're going to sit for the IGCSE Chemistry, Cambridge IGCSE Chemistry this June or the upcoming November, please put this in the comments section below. I would really like to know how many of you are taking the exam this year. Thank you very much, and see you in the next video, which, as I said, will be about the addition polymerization of alkenes, and part number 10 is going to be about the addition reactions of alkenes.